you want to secure your application. Well, the best place to start at that is looking at the OWASP top 10. These are the top 10 most common security issues that we're seeing out there. Now, if you're new to the OWASP top 10, it's updated every 4 years. This year, the latest is in 2025, and the one before that was in 2021. And this is a mammoth project done by the great people at OWASP, stands for Open Web Application Security Project, and it looks at the security challenges that we are facing. The difference between 2021 and 2025 is that things have kind of shifted around a little bit, and then there's 2 new additions. There is the introduction of the software supply chain failures. Now, this replaced something called outdated or vulnerable components. They're a little bit similar, but what's important is this better reflects what we're actually seeing now. And the other new one is mishandling of exceptional conditions. So you'll never guess, but in this video, we're going to quickly go through each one of these and explain what they do. Now, I have detailed, in-depth videos on each of these topics, so if you really like hearing my voice, I'm sure you'll be able to find them at this channel. But this is going to give you an idea of what are the common vulnerabilities in each category and what potentially can we do to solve them. So let's start off at the obvious place of number 1, broken access control. This is maintaining its number 1 spot from previous versions. Broken access control can be simply explained as when an adversary or a user can access data or information that they're not supposed to. Well, there are a few vulnerabilities that we find. The main one is called IDOR. It stands for Indirect Object Referencing. This is actually the number 1 bug that's reported in bug bounty programs like BugCrowd. Now, IDOR in its simplest form is manipulating a request, changing things like the user ID to access someone else's information. So, to explain this simply, imagine that you have a banking website, and at the top in the URL, it has ID equals and then the user ID. Let's say this is 123. Now, let's say that you change this to 124. If you then we're showing someone else's banking information, this is an IDOR problem. And the reason why this happens is that we authenticate a user into the site, they're properly authenticated, and the application knows this. But it doesn't check or do additional checks, doesn't control the access so that you can't see other people's information. Now, the URL bar is like a simple version of this, but typically it will be more like manipulating an API call or a GET request with various information. There are also other versions of this, like privilege escalation. This may be if you're a standard user, but you manage to bump your privilege to admin, for example, using similar methods. Missing object level authorization. This happens when an API doesn't check that you're authorized to access a certain artifact or object. Missing function level authorization. This is when you're able to perform a task that only an admin should do by making a GET request again, for example. And another really common one is something called path traversal. And this is when you're able to specify the path to access a file that you probably shouldn't have. The most common is kind of going back levels and being able to find some infrastructure files that may have passwords or environment variables in them. So how do we solve broken access control? Well, there's a number of security tools that you can use. This is best found with something called SAST, Static Application Security Testing, DAST, Dynamic Application Security Testing, or if you want to get really fancy, you can do Agentic AI Pen Testing, just to throw some buzzwords in there. If you're looking at this in the future, I'm sure at some point I'll make a video on Agentic AI Pen Testing. I'll put it here if you happen to be in that future. If not, there's nothing there, so don't worry about it. Right, let's move on to number 2. Now, this actually jumped up from number 5, and that's security misconfiguration. So a lot of the other OWASP top 10 are looking at issues in your actual application, something that may be introduced by coding issues in when you're building out your app. This is more looking at the infrastructure that your application sits on top of. So more and more common today, cloud infrastructure, for example. So there's a couple of really big ones in this. Number 1 would be having your storage or data storage public when it shouldn't be. So the most easy one to talk about this is public Amazon Simple Storage or S3 buckets. So these are kind of data storage devices that you can put out there. Now, typically they're meant to be private or they are private. Sometimes you may want a public data bucket, but if you don't specify that this should be private, then it often will end up being public. And if someone is able to access that, then they can just access all the data. There's endless breaches that have been caused because of public S3 buckets. Another big one is that when you deploy your infrastructure, it may come with a sample application, right, to help you understand how to deploy something. Now, often these have known vulnerabilities in them because they're meant to be just, a sample. It's not really a big deal, unless, of course, you leave that sample application there. And if that vulnerability actually allows an attacker to exploit that sample application and get to your cloud layer, your infrastructure layer, then they can do all kinds of nasty things. So what tools do we have to kind of identify security misconfigurations? Well, there's two main ones, IAC scanning and CSPM. Lots of acronyms in security. IAC stands for infrastructure as code, and the scanning is basically tools that we use to analyze our infrastructure as code files to identify if we've made any mistakes, like we've made data public or we haven't used the right cryptography. It's very similar to SAST, but for our infrastructure. The other area is CSPM, Cloud Security Posture Management, and this is actually looking at your assets in your cloud. I've made videos of both of these tools if you really want to get into it, but basically CSPM is looking at your infrastructure as it is live, and infrastructure as code scanning will be able to detect it before it goes live. But you need both. The OWASP Top 10 number 3, or the third most common vulnerabilities, falls under software supply chain failures. So the software supply chain is something really important we need to understand. It's made up of things like our dependencies, our open source dependencies that we use. Around about 75 to 90% of your application are built on these open source dependencies. And this one is easy to talk about. There's been lots of compromises of these packages. For example, in 2025, Debug, Chalk, ANSI styles were all compromised via one phishing campaign. In total, the packages that were compromised in this one attack were downloaded 2.6 billion times a week, right? And the impact of that was massive. And attackers love to target this type of supply chain because they can have massive spread, right? They put malware in one package and it can go across into millions of applications. But your software supply chain is more than just your open source packages. It's also things like your IDE, the tool that you use to code, something like VS Code or Cursor. A big trend right now is turning VS Code extensions malicious. Now, this is especially true for VS Code clones like Cursor and Windsurf. And what this does, if they can turn or they can create a malicious extension, they can steal secrets or other kind of credentials from your local machine. Other parts of your software supply chain may be things like your CI/CD pipeline where you're testing your application. All of these are parts of it, and attackers really love going after this because they can invest a huge amount of resources and target lots of areas. So how we combat that, traditionally we use something called SCA, Software Composition Analysis. And this basically looks at all the dependencies in your application and do they have any known vulnerabilities. Now, this is still a component that we use, but there's a whole bunch more. We also need something called malware scanning. But this is really looking for malware in all the components like your VS Code extensions and your packages. I don't want to get too deep into the whole malware detection thing because then we need to talk about databases and real-time updating. But just understand that that's the tool that you're going to need to secure your software supply chain. All right, cryptographic failures. This one's actually gone down a bit. I think largely because it's quite easy to spot these with the tools that we have. So the most common cryptographic failure that we kind of get is using insecure cryptography hashing algorithms. So for example, there's a hashing algorithm called MD5, and we should not use this anymore because it's proven that we can actually crack this algorithm. It's still quite difficult, but it's possible. So basically what that means is that if you have enough resources, you're going to be able to crack it. So now we have much better algorithms that we can use. And maybe things like not using adequate seed phrases or seed passwords for our cryptography. So back to kind of weak password type stuff, and not sufficiently encrypting sensitive data. And not sufficiently encrypting data, particularly when it's in transit, when it's moving. So sometimes we will encrypt the data when we capture it and we store it, not knowing that actually when we're sending data, that can be intercepted. And if we're not applying the correct cryptography during transit, this can be a bit of an issue. How we detect this is typically the best tool that we can use this is SAST, Static Application Security Testing. This looks at your code and it'll be able to pull out the cryptography. Now, you can also use tools like DAST, but the best place to kind of catch it is in the code. And this is something that we typically can catch at that code level really well because it's obvious when you're using crappy cryptography. The OWASP Top 10 number 5, or the fifth most common vulnerability, is injection. I'm really happy to see that this one has fallen a couple of spots. It was number 3, now it's number 5. And injection is kind of like the first kind of hacky thing that you learn as a developer. And it essentially comes down to injecting code into what we call untrusted data. or user impacted data. So if you have an input field on your website, instead of putting text in there, if you put some form of code, you may be able to inject code into the application and get it to run. So it's easy to kind of understand that, yeah, if we have kind of user input fields, we can do this, but typically injection will be found at kind of a GET request level. But if you sniff out a GET request and you put your own code in that GET request, that will have a much higher chance of being successful than in a user input field on a website, for example. And that is because how we can deal with this is something called escaping. We take dangerous characters like semicolons and quotation marks, and we escape them. Right? So we kind of render them into kind of strings, or we turn them into kind of a hex value or something like that. Sometimes we can do this kind of on the front end side, but forget about the back end side, which is why kind of doing it at the request level is much better. There's lots of types of injection. There's SQL injection. This happens when you're not using prepared statements or parameterization when you're interacting with your SQL database. There's no SQL database, so different types of database injection. There's cross-site scripting. This is when you can kind of embed code permanently onto a site and get it to talk back to, an attacker server, a C2 server or something like that. There's various methods of this. There's code injection. There's lots of stuff, but they all follow the same principles. You have untrusted data, user manipulated data, and instead of kind of putting text in there, you put code, and if you can get something to run, you have an injection attack. So how do we solve this? Well, in our code, we want to do things like escaping untrusted data, or we want to make sure that we're using prepared statements. There's various methods. How we can ensure that is with tools, again, like SAST, Static Application Security Testing. This is really good. And DAST, Dynamic Application Security Testing, is another great example. DAST is kind of like will run a series of scripted attacks against your site. And often that will be trying to inject code into a request or using an API in a malicious way. And this is a good way to understand if we have any injection attacks. The sixth most common security issue that we have, one that used to be number 4, is insecure design. And this one's kind of difficult to talk about and to spot because it relies on something called like logic flaws. So I'm going to give you just kind of like a very simple example. It's kind of stupid, but it will help you understand it. If you have a banking application and you have a user called Alice that wants to send Bob $20, but if Alice manipulates the request and sends negative $20, what happens? Does it deduct money from Bob? Does it credit Alice? Does it break? Thinking about this scenario, if this was true, then you would have an insecure design scenario. Coinbase had a funny one where you could actually kind of have infinite money on Coinbase. It's a real example. It's in a video if you want to go and check that out. But it's really thinking about how does the logic of your application kind of work out. Now, this is a very big example. There are smaller examples. A common one is when you have an error message that pops up and it contains sensitive information. The design of that error message was insecure because it's giving an attacker potentially useful information to attack you. So that's another common area. Now, some insecure design, like the error message example, you can discover with tools like SAST, DAST, and other areas that we talked about. But the logic flaws are notoriously difficult. And this is something that AI coding or vibe coding, if you will, is notoriously bad at. Because like these AI tools will make a whole bunch of assumptions. And if you don't explicitly say that I don't want a user to be able to send negative money in my banking application, then the AI may build that into it, right? And that's because these aren't vulnerabilities as we've done something wrong. It's just that we haven't thought about it correctly. So the best tool that we have at our disposal for this is something called threat modeling. And threat modeling, and there's acronyms that you can look in like STRIDE. And this is essentially having an exercise where we put on our black hats, we think like an attacker, and then we try and target our application. OWASP Top 10 number 7 is Authentication Failures. Now you may be thinking, hey, that sounds an awful lot like OWASP Top 10 number 1, Broken Access Control. Well, they're kind of similar, but they work on different areas. Broken access control is all about authorization. What do I have the authority to do once I've logged in? Can I access other people's accounts, information that I shouldn't have? Broken authentication is all about the logging in process, the authentication process. So there's a couple of easy ones to talk about just to get the concept around. So there's an attack path called credential stuffing. And it's kind of similar to brute forcing, but just with a little bit more logic behind it. So if you have a known username, and you're trying to log into their account by guessing their password, this will take forever if you're just using kind of a brute force attack. You can add a level of sophistication to a dictionary attack, or you can add a level of sophistication and do credential stuffing, which is taking known passwords from different breaches. So for example, there's the RockU password set. It's publicly available. It has 3 million known passwords in it. It's kind of dodgy, but it's out there in the wild, so we might as well talk about it. Credential stuffing is I'm taking my known user and I'm going to stuff all of these passwords from the RockU password set into it. Right? Now, one of them may work. You will be surprised how quickly you can get through 3 million passwords if there's nothing in place to stop you. Right? So if you've ever logged on to a site and it's come up letting you know that, hey, you have 4 more password attempts before we block your account, this is a way to stop credential stuffing. If you've made multiple login attempts and all of a sudden more and more complex reCAPTCHAs come up where you have to fill in little puzzles or look at the blurry numbers, this is a way of slowing down or stopping credential stuffing attacks. Other areas like multi-factor authentication, right? So making sure that you have mechanisms that stop automated attacks is basically a big one. Another very common authentication issue is using admin or default passwords. So the easiest one to talk about in this is good old WordPress. You remember that thing, WordPress, that was really popular like 10 years ago? Well, it still exists out there. It's still very popular, and it's still causing a lot of troubles. One of the biggest issues with WordPress is that when you rolled out a new instance of your WordPress, it created your front page and a backend for you to manage your page. By default, the backend credentials were admin, username admin, password admin. Most people didn't actually change this, right? They just left it. The idea was that once you set it up, the first thing isn't to come up with a pretty new design for your blog. It's to come up with new passwords, new credentials for your admin panel. If you didn't do this and you used the defaults, then thousands, if not millions of WordPress sites actually got compromised because of this simple error. And it's actually way more common than you would expect it to happen. The last thing I'll talk about in this for kind of a vulnerability is the secure process to reset a password. This is something that attackers use all the time to get in, relying on those unsecure pathways to reset a password. So this may be using something like, what's your childhood's best friend name? What's your mother's maiden name? All this information is findable, right? Especially out there with all the social media. So this is not a pathway to reset your password. So what do we actually use to get on top of authentication failures? Well, usually I talk about tools to help us uncover this. And there's tools, we'll get to that. The main thing, the number one thing, and if you're listening to this and you're building an application, if you're about to put in a prompt in Lovable or Replit or something, here is the biggest advice that I have for you. Please use a trusted authentication provider. Something like Okta, for example, or Auth0. Authentication is complicated, it's difficult, and it's very, very critical. There's no point for you to build this yourself. There's trusted service providers out there that will immediately set you up with things like, sign on with Google, like SSO, right? Sign on with Facebook. All of this is automatically done for you if you use a trusted authentication provider. So that'd be my first step. Now, if you are insane and you want to write your own authentication, then you want to make sure that you're putting this absolutely through the ringer with tools like SAST to scan the code for it, identify vulnerable patterns. This will help using things like DAST to be able to test it, to be able to test things like credential stuffing campaigns, or maybe even tools like Burp Suite, which are more offensive tools that can recreate the attack paths. So if you are going to write authentication, you're going to have to put yourself through a lot of misery to make sure it's secure. Pro tip, don't. Get someone else to do it. Pay for it. There's free versions out there. There's open source versions. Don't do your own authentication. All right, let's move on to top 10 number 8. The 8th most common vulnerability, according to OWASP, is software or data integrity failures. This one's an interesting one, and it's basically when we take untrusted sources of information and we don't validate it. So an easy example to talk about is if we use cookies a lot in applications, right? These are very helpful, but cookies can actually be manipulated and replaced. So if we don't ensure that the cookie that we're relying on actually comes from the chain of command that we expect it to, we haven't checked its integrity, an attacker could inject their own cookie, and maybe this elevates their privileges or it changes the way that the application works. So this is kind of like a common example where we're not checking the integrity of it. Another area of this would be if we're kind of allowing the downloading of our application, but we don't have a process that checks the integrity of that. So let me give you an example. Let's say that you have an open source package on NPM. The process of how that's meant to be is that it you upload the code into GitHub. GitHub runs GitHub Actions, their CI/CD pipeline, and then it submits that to NPM and the code gets updated that way. If an attacker can steal a developer access token, then they can skip that integrity and skip the CI/CD pipeline and just inject malicious code straight to NPM. Now, the reason this happens is that we haven't only allowed for the package uploading to only come from one trusted source, the GitHub Actions. This makes it much harder for an attacker to be able to kind of bypass that. So that's another example of a software or data integrity check failing for us, is ensuring that the process is all being followed and the data or the package or the software or whatever it is coming from a trusted source. So we need to ensure that. Now, some security tools will kind of help us find this, but it's actually pretty difficult. And the tools that we kind of have available are things like signing, when we create a hash from processes and we only allow hashes that match. But it's a difficult one to find. And there's a variety of security tools that we can use that may help. But this is interesting because it really comes down to kind of, I guess, a little bit into design, the pipelines of how we create software. All right, almost there. The 9th most common vulnerability, according to OWASP, is logging and alerting failures. Now, this one is interesting because there's a bit of crossover here between insecure design, because, I also consider failing to log and kind of overexposed alerting messages part of insecure design. But here we're specifically really looking at kind of our failure in how we're dealing with logs. So we need to make sure that we keep great logs of everything happening in our application live. And one of the reasons why is that if our application, is being used out there a lot, we want to know immediately if someone's trying to be malicious, right? If we're seeing logs with injection payloads, or if we're seeing kind of logs of someone trying to log in lots and lots. And then we can use tools that monitor these logs to actually let us know when something's happening. Now, if we don't have these logs, not only does it make debugging an absolute nightmare, but we're kind of invisible to it. This one was also there in previous version, but they've changed the name and they've specifically really emphasized on adding in the alerting. Because, and I guess this is because that maybe you're doing great logging, but you have nothing to alert you, right, when something's going wrong. So that's like a pretty big oversight. So they've changed the wording of that to be like, okay, you need to log, but you also need to like be alerted when something's going wrong. I kind of find this a little bit funny. But that's essentially what this is making sure we've got logs of everything that's happening and that we can identify when someone's being malicious or someone's just up to no good in our application. And the 10th most common vulnerability, according to OWASP, is mishandling of exceptional circumstances. This one's kind of interesting to talk about. All the other areas that were talked about, we've kind of looked about attackers being methodical, right? And injecting code or compromising supply chains, things like that. This one's a little bit kind of more chaotic. So exceptional circumstances can kind of be what happens when a user uses your application in the weirdest possible way. What happens if someone sends a request not in English or using a Latin alphabet? What if they're using Cyrillic or Chinese characters? What happens if someone puts Unicode characters in there? What happens if someone sends like a really, really long payload? This is a really fun one to actually kind of test against because there's a tool called fuzzing. So I've talked about a different tool called DAST, Dynamic Application Security Testing. And this is a kind of an automated process that kind of attacks your application in a very structured way. It's going to inject code. It's going to do this. It's going to do this. Fuzzing is just kind of like, it's absolutely chaotic friend with ADHD that's just absolutely kind of causing havoc. I have ADHD, so don't be offended by that. That is me. I am the fuzzer in the world. But anyway, fuzzing is basically not attacking your application in a structured way. It's attacking your application in an absolutely chaos way. It's throwing really long payloads. It's going weird characters. It's kind of doing all this stuff to see how your application deals with it. Does it log it properly? Does it handle errors correctly? Or does it break things? Does it create kind of memory issues? Does it kind of allow security vulnerabilities to appear, but in very weird ways? And this one's kind of a lot of fun. And I'm really glad that it's been kind of brought up to the OWASP Top 10 because, I kind of like talking about it. Well, anyway, we've come to the end of the video. That is the update for the OWASP Top 10 and some security tools that you can use around it. I hope you enjoyed this video. Make sure you like it, subscribe to the channel. Chief Fuzzing Officer out, and I'll see you on the next video.